Boolean binary and non-types in Python. These are more built-in types that show up often. So the values true or false are bool type. Binary types convert the text to binary. But binary type or the byte type cannot be changed. Byte array can be changed. So you could replace the value of any of the characters. Non-type represents nothing, or absence of a value. This is an example of byte type. We are converting the ASCII string hello to bytes by adding in b at the beginning. Then for the first byte, we are going to modify the letter h to j. This will error. This is because bytes object does not support assignment. So you cannot change it. So if you want to change your data, you need to use byte array rather than bytes. Byte array requires you use the class constructor and pass in the byte string. And then you can replace the first character. Over here, because byte array can mutate. Here you can see I have replaced h with the ASCII character code 74, which represents the letter J, and you see the output jello. If I change that to 75, that will give us the letter K. So now we have jello. None type here you can see is returned when a function doesn't return a value. Greet is the function. It does not return a value, so you end up with none as the return value stored into this variable. None represents absence of a value in Python. If you are from other languages such as SQL, this is like the null in SQL. Read-write, compress data in Python with binary type. We will use gzip module to compress the string hello. The issue is compress function takes in binary data type. So you can use b in front of your string to convert it to binary. Then you will write the output to a file where your Python code is running. Running this will create the file. You can then open the file using the open function. That will give you raw compressed data. You can see the type is bytes of the data that you read. You then need to decompress the data using gzip module and decompress function. When you then print the output, you will get the original data that you had. Notice it is still binary type. And here is the output file. If you open that, you can see there is a file within here. The file is compressed. This is the compressed file. If you open, it will open up in Notepad and you can see your compressed data, which is what we printed in VS Code. So we got hello world here, and in our file we compressed it. Opening up and then opening the file up gives you the string hello world. Just use the gzip module. Compress the data. Make sure you convert it to binary, as this function accepts binary only. It has other parameters that you can pass and set as the compression level of 0 to 9 and the modification time. By default, it just uses the current time. And then to read it back, open the data. It will be in the bytes format, and then you can decompress it and print the original data that you passed in, explicitly setting a type in Python. Python can let you force a type if you want. You can use the class name of the data type because it has a constructor that will take in various data types and convert them into that particular data type. What I mean by that is running this code, you can see I passed in number 55. This number 55 is integer because it doesn't have quotation marks like this. By having no quotation marks, this is integer. The string class has a constructor. Think of it like using a function even though it's a class. It has a default function or what is known as a constructor. It can take in various data types, including integer. It will convert that integer into string. Here you can see I'm using list data type name. The class name is list. Open parentheses, close parentheses, but I am passing it a tuple. A tuple has these two numbers in it. I wanted this to be a list, I pass it into the list class. It will then output 8 and 9 with these square brackets which represent a list. And I am then printing. We are printing the type of these values. So you can see the data type is list and this one is a string. If you had quotation marks around this and you wanted that string the user has typed to become an integer, you can use the int class. And by running this, you will see it will change it to int even though it's a string passed in by the user. And now you can see it has changed the string into int just by using the integer class. Use the class constructors to convert data types explicitly. Make sure you like, subscribe, and follow. Leave a comment to show your appreciation. Python Data Types Challenges Quick Practice Walkthrough. Why does adding these two lines give a weird result? 4 plus 6 gives us 10, but 4 plus 6 gives us 46. The reason this becomes 46 is because of these quotation marks. This is a string and this is a string. Using the plus operator joins the strings together. But numbers add when you use the plus operator. If a user gives you the input of the string, you need to convert it to integer if you want to add them together. To do that, you can wrap your inputs into the int data type constructor. This will convert the 4 into integer, but you also need to do it for the other number. Here's our as the user has provided. This will now correctly show the answer is 10. Here is the correct output. Adding a string to a number will cause error. Here you see we get type error. Can only concatenate string not into a string. So we have a string we are trying to concatenate against a number which is invalid. You need to convert the 5 into an integer by passing it into the integer class constructor. Think of constructor as a function of the class, the default function. So sometimes input comes in as text. We must convert it before doing math on it. Here we get input from the user as 3.5, but this is a string. We want to convert it to a decimal. Python decimal is a float. Then you can do int, so we use int and float to convert strings into numbers before calculating. Is this true or false? Comparisons in Python return a Boolean value. Either true or false. 5 is greater than 3. This is true. 2 is equal to 4. This is false. 10 is not equal to 10. This is false. These symbols compare values. The result is always true or false. And the type is Boolean for the output of the comparison operators. Even small changes like adding quotes changes everything and cause errors in your program. Convert your data types using built-in functions such as int, float, and check the types using the type function. Ever wondered how Python handles numbers? Python has multiple number types. We will look at 2 in this video. Integer and float. You can store the numbers in a variable. X over here is integer. Y is a float. Python is handling both automatically. You do not have to explicitly say what these numbers are. Numbers are one of the simplest yet most important data types in Python. Whole numbers or decimals like this, Python handles both effortlessly. Again, here we have integer. A is equal to 7. B is equal to 3.14. This would be a float. You can check the type using the type function. Here, this is a whole number. So it is an integer. This is a decimal. So it is a float type. Integers have no decimals. As you can see, here floats do have a decimal point. Python distinguishes them automatically. You do not need to add anything additional. How to do basic arithmetic operations in Python. Want to do math directly in Python? Watch this. Addition can be done with the plus operator. You put one variable on the left side, then the next variable on the right side. Here we have x is equal to 9, y is equal to 4. This gives you 13. Subtraction is done with the minus operator. This is the dash symbol on your keyboard. This gives you 5 as the answer. Multiplication can be done with the asterisk or the star sign on your keyboard. In this instance, we get the answer 36 when we multiply the two variables together. Division returns a float. So here you can see we get a decimal. This is float type in Python. The answer is 2.25. This division is done by the / on your keyboard. If you do 2 /, the double / you get floor division, it returns the integer part. Here we get 2. The double / only give the integer part and it will be floored towards the number 2. The flooring part is important to understand. Here you have 5.9 divided by 2 which gives you 2.95. The flooring of this number will always return towards rounding down. So it will round down to 2.0, which again you will notice is 2.95. This is because the input type is float. However, over here these were not floats. So you did not end up with a float. You ended up with an integer. Floor division does not mean removing decimals. It means round down towards negative infinity. In this example, we have 5.9 divided by 2. The decimal answer or the float answer is 2.95. With floor division, it will always round down. In our school, when we learn division and to take it to the next integer, we would look at if it was 0.5 or greater. If it was 0.5 or greater, we would increase this number to 3. But with Python floor division, it will always round down. So 2.95 becomes 2.0. The negative effect is when you do the same number but add a minus sign. Then you get minus 2.95. Floor division means it will round down. In this instance, it is rounding down to minus 3. It always rounds down. Rounding up would have meant 2 minus 2.0. The int function simply truncates the decimal point. 2.1 becomes 2. 2.95 becomes 2. Minus 2.95 becomes minus 2. Int function simply removes the decimal part. It truncates or cuts it off without rounding up or down, leaving you just with the integer part. Use the floor division to round down. Use int function to simply chop off or cut off the decimal part. Python can do powers and remainders too. Let's take a look at the exponent and modulus operators. Here you can see I have two variables, x and y. The exponentiation operator in Python is the asterisk sign. But you have to do two asterisk signs. 5 to the power of 2. This will give you the answer 25. The modulus operator is the percentage symbol in Python. Here 5 is divided by 2, which means you get an answer of 4 with one remainder. So the modulus operator gives you the remainder. You can also use it to check if a number is even or odd using the modulus operator. If you divide a number by 2 and if the answer that you get for the remainder is 0, then that means it's an even number. But if you get an answer that is not equal to 0, then it's an odd. So here you can see that is if you divide a number by 2 and we have number of remainders. But 7 divided by 2, we end up with one remainder. This means if you get 0, it's even. If you do not get 0, then it is an odd number. You can also use it to cut time from 24-hour clock to a standard 1 to 12-hour clock. Here dividing 19, which is 7 p.m. by 12 will give a remainder of 7. So 19 hours is equal to 7 p.m. If you were to do 14, which would be 2, you can see the modulus operator gives you the answer 2. And the same would apply to 22, which would give you 10 o'clock at night. So you can see how useful the modulus or the remainder operator is in Python. Modulus operator with negative numbers is interesting. you're dividing -7 by 3, which gives you a remainder of 2. The 2 number is a positive. Python keeps the same number sign as the divider. Since divider here is positive, we will get a positive answer. This may surprise many people, but mathematically it makes sense. Converting number types and complex types in Python. Need an integer instead of a float or vice versa? Python can convert easily. Int function converts to integer. Running this code, you can see the variable x is being converted using int class constructor function. 3.9 over here becomes the number 3. You can see the class type changes to int. To convert a number such as int, in this case 5, into a float, you use the float class and its constructor to convert the input into a float. So 5 here becomes 5.0 and the class is float. For the float, Python adds the decimal point automatically. For the integer conversion, it truncates the decimal part. No matter what the number is, it will always be the same. Python even handles complex numbers, real or imaginary. Here I have a complex number. 2 is the real part and 3 is the imaginary. Running this code, the complex number is printed. The real part is accessed via the real property and the imaginary part is accessed via the image property. So 3 is the imaginary part and 2 is the real part. Python uses J for imaginary. This is useful in math and engineering. Just remember the int function will always truncate. It won't round up or round down. It will simply ignore the decimal part. So do not use it for rounding mathematically, as it will only truncate the decimal part.